Assalamu alaikum. In this video, we will talk about LeetCode problem 746 mean cost climbing stairs. So let's start it from problem statement. So here says that you were given an integer array cost and okay. So once you pay the cost of each index, you can either climb one or two steps. Okay. So and you can either start from the your move, that is your step for index with index 0 or index 1, and return the minimum cost to reach the top of the floor. Okay, so let's explain the uh, statement. That is, let's this is your array, cost array. These are the indices 5, right? So there says that if you pay the cost of this index, right, you can go from index 0 to index 1, either index 0 to index 2. So there are two possibilities for each index, right? That is index I plus 1 or I plus 2, right? And there also says that you can start your step from index 0 or index 2. These two are possible. Okay, so these two are valid. And anyway, you have to reach top of the floor, that is greater than 5. It could be 6, 7 or anything. Anyway, so anyway, you could reach the top of the floor, but your cost should be minimum. Your cost should be minimum. Okay, so I think you got the statement. So now talk about uh, example 1. Okay, so let's see. Let's assume that you are at index 0. So from index 0, you can go from index 0 to index 1. So from index 1, you can go from index 1 to index 2. So from index 2, you can go from index 3. So see that index 3 is the top of the floor, right? So you cannot pay the cost for index 3 because you done your task, right? You reach the top of the floor. So if you pay cost for index 0, 1, 2, you can reach there. Huh? Yes, this is your possibilities. And okay, so you also go from index 2 to index 4, right? So where is 4? 4 is the top of the floor, right? So okay, now see that from index 1, you can go from index 1 to index 3, right? Index 3. So you see that index 3 is the top of the floor. That is, if you know index 0, index 1 value, then you can go from index 2. That is, if you pay cost for index 0 and index 1, you can reach the top of the floor. So now you save for index 1. For index 1, your cost is from index 1. From index 1, your cost is index 1 plus index 3 cost, right? So index 3 cost is 0 and index 1 cost is 15, right? So from index 1, your cost is 15, and index 2, your cost is sorry, from index 2, your cost is 20, right? So here from index 0, you can go index 2, right? From index 2, you see that you already calculated minimum value for index 2, right? For in index 2, you can uh, reach top of the floor with 20, minimum cost 20, right? You already calculated that, because from 2, where you go index 3 or index 4, but you already calculated that, right? See there, you already calculated, so you cannot further call from index 2 to 3, 4. If you save anyway for index 2, that is enough. You cannot call further. Okay, so see there, for index 2, you your cost is 20 for index 0. So for index 0, your cost is cost of 0 plus 2, right? Okay, so that is 30. Okay, now there says that you can start your step with index 0. So for is index 0, your cost is 30, right? So for index 1, you can also see that you can also start your move from index 2, right? So let's assume that from index 1 you start now index 1. So see that when you call index 1 from index 1, you already calculated for index 1, right? Minimum value for index 1, right? Because for 1 you can go from index 2 or index 3. You already calculated for 1, right? So you cannot further call from index 1 to 2 to 1 to 3. You cannot call because you already calculated for 1 for 50. So for 1 your cost is 50. So and so that cost for minimum value is 15, right? So that is your answer. I think you got the solution. Okay, you got that point. So now let's so now for example 2, let's see a visualization. Okay, okay. uh, so from index 1, I assume that the array is index 1 base, that is you can start your move from index 1 or index 2. Okay, so from index 1 you can grow index 2, 2 to 3, 3 to 4, 4 to 5, 5 to 6, 6 to 7, 7 to 8, 8 to 9, 9 to 10, and 10 to 11. So 11 is in out of bound, right? So see that from 11 your cost is 0, and that is 10 to you also go 12, right? So 12 is your top of the float, that is for 10 your cost is 1, right? Similarly 9 to 11, so cost for 9 is 100, right? So from 8 you call index 10, right? So you already calculated for index 10, right? So you cannot further call any more, right? So for index 10 your cost is 2, right? Okay, so for index 7 it cost is 3. Similar for 6 it cost is 102. For 5 it cost is 4. For 4 your cost is 5. For 3 your cost is 5. For 2 your cost is 106. For 1 your cost is 6. Okay, so that is the result for example 2. I think you got the visualization, and let's see the code for this problem. Okay, there here is my DP code. Let's see that if your indexes is now at top of the float, that is greater than n, right? So then you return 0, right? You cannot pay for that, right? Okay, now ignore this two line, ignore this line. uh, there if you pay the cost for index, this index, then where you go, you can go from index I plus 1 or index I plus 2, right? So you take the minimum from these two, right? Index I plus 1, index I plus 2. So there. Okay, so you save for this index there, right? That is initially for our DP array content for each value is -1, that is, and now you can see the this line, if your DP index value is not -1, that is you calculated for this index, right? So you can return from there, that is like that. If you are at index assume you are at index 7, right? So you already calculated for index 7 to 9, you call index 7 plus 2, that is 9. So you already calculated for 9, right? So you cannot further call that. So why, that is why when you call 9 you return from there from 7 to 9 to 7. So you further don't call them. So that is actually this line, and this line save your exponential time, right? So, and this is the DP approach for this problem. I think you got the solution approach for this problem. Thanks for watching. Uh, Assalamu alaikum warahmatullah.